Hello, mathematicians. This is the video for home connections 65 and 66. Number 1, fill in the bubble to show the equation that is correct. So we're looking for the right one. The first bubble, 1 1/4 plus 1 1/4 would be 2 2/4. So that one is wrong. The bubble right below that, 4 3/12 plus 2 9/12 would be 6 12/12, or 7. So that one's wrong. 5 2/8 minus 3 1/8 would be 2 1/8. So that one's wrong. I'm guessing it's the last bubble, but I definitely want to be sure that that is the correct one. 3/10 plus 32 hundredths. If the denominators are not the same, so I know that 3/10 is the same as 30 hundredths. Now I can add 30 hundredths plus 32 hundredths is 62 hundredths. So that's the correct one. All right, number 2, fill in the bubble to show the equation that is not correct. So they're really making our brain think. Now we're looking for the one that's wrong, and that's the one we need to put a bubble by. 6/10 plus 15 hundredths. If the denominators are not the same, I know that 6/10, if I multiply the top by 10 and the bottom by 10, it's equivalent to 60 hundredths plus 15 hundredths is 75 hundredths. So that one is correct, but remember, we're looking for the one that's not correct. Right below that, 5/12 plus 7/12 is 12/12. So that one is correct. 7/8 minus 3/8 is 4/8. And 4/8 is the same as a half, not a third. So that one is the wrong one. So I'm going to put a bubble there because I'm looking for the wrong one. Let's just make sure that last one is correct as it's supposed to be. 10/12 minus 4/12 equals 6/12. And 6/12 is a half. So yes, that one is correct. So the bubble is next to the wrong one. Okay, number 3, they're really making us think. Fill in the bubbles to show the comparison statements that are correct. So we're looking for the correct ones, and there's going to be more than one of them. All right, so we're looking for the correct ones. I like to put a 0 in certain places so they all go up to the same place value. Then they're easier to compare. What's bigger? Sometimes thinking of money is helpful. 30 cents or 3 cents? Well, 30 cents is bigger. So that one is wrong. The one right below that, again, I'm going to make them both go up to the hundredths place. So what's bigger, 60 hundredths or 49 hundredths, or 60 cents or 49 cents? Yeah, 60 cents is bigger. So that one is correct. And again, I'm looking for the correct ones. There might be more than one, so let's keep going. 2/8 is the same thing as 1/4. Are they equivalent? As long as you do the same thing to the top as you do to the bottom. If you cut 2 in half, you get 1. And if you cut 8 in half, you get 4. So yes, they are equivalent. So that one is correct. So I'm going to put a bubble by it. And the last one, if I put a 0, 70 hundredths is equal to 70 hundredths. I was only expecting 2 to be correct, but actually, there's 3 of them that are correct. So this one's going to have 3 bubbles. Number 4, fill in the bubbles to show the comparison statements that are not correct. They're so making us think. Now we're looking for the ones that are wrong, and there's going to be more than one. 5 hundredths is the same as a half. No, a half is the same as 5/10. So those are not equal to each other. So that one is wrong. And I'm going to put a bubble by it because remember on this one, I'm looking for the wrong ones. 4/10 is the same as 60 hundredths. Well, I know 4/10, I could put a 0 here, is the same thing as 40 hundredths. 40 hundredths is not the same as 60 hundredths. So this one is wrong, which means I need a bubble because I'm looking for the wrong ones. The next one, if I put a 0 here, I know that 3/10 is 30 hundredths. Is 25 hundredths greater than 30 hundredths? No, that one's wrong as well, so I got to bubble that one too. And the last one, 6/10 is less than 60 hundredths. Well, let's see, 6/10 is the same thing as 60 hundredths, so there should be an equal sign there. 6/10 is actually the same thing as 60 hundredths. They don't have an equal sign there, so that one's wrong too, which means number 4, all of them are wrong. All of them should be bubbled. Number 5, putting numbers on a number line can be kind of tough. I always start with the easiest ones first. And I like thinking of halvesies, right? Right in the middle of 0 and 2 is 1. And now let's do what's right smack in the middle of those as well. Right smack in the middle of 1 and 2 is 1 and a half, or 1.5. So that was an easy one, I think, to place. And let's think halvesies again. Right between 0 and 1 is a half. Right between 0 and a half would be a fourth. And right between a half and 1 would be 3/4. So I'm thinking 1/4, 2/4, 3/4, 1. So I think that first gray box looks like it's right at 1/4. So I'm going to go ahead and put 1/4 right here. And that third gray box looks like it's at 3/4. And I don't see 3/4 as a fraction, but I do see 3/4 as a decimal. Remember that 3/4 is the same thing as 75 hundredths. 0.75, I could think 3/4. Okay. Let's see, if I look beyond the 1, I would say that looks right smack in the middle of 1 and 1 and a half. And that looks right smack in the middle of 1 and a half and 2. So right after 1 would be 1 and 1/4. And right after 1 and a half would be 1 and 3/4. And I only have one gray box left and one fraction left. Think of a quiz. If you got a 3 out of 8 on a quiz, you got slightly less than half of them right. And if you look, that gray box does look slightly less than that halfway mark. So I think that works out just perfectly. So 3/8 is slightly less than 1/2. Okay? So with number lines, it's always best to start with ones that you know, and that helps you place the ones that maybe are a little bit more challenging. Let's look at Home Connections, page 66. And we need to do some shading here. They've done the first one for us. Let's look at the one right to the right there. I see that 4 strips are shaded. 4 strips would be 4/10. I could also think of that as 40 hundredths. You don't have to write 2 fractions, but it's good to remember that 4/10 is the same thing as 40 hundredths. The decimal for 4/10 is 0.4. The decimal for 40 hundredths is 0.40, both of which are equivalent to each other. The next one, I have to do some shading, 75 hundredths. I could shade 75 in a couple of different ways, okay? But I think I'm going to shade it like this and say there's 25, there's 50, and there's 75. And I can think of 2 fractions. Probably the first one people are thinking of is 75 hundredths, right? 75 out of 100. And hopefully some people are also thinking that's the same thing as 3/4 of the picture. They might even think, well, 3/4 is 75 cents, so it's 3/4 of the picture, 3/4 of the picture. And the last one, 6/10. I know that 6/10 is 0.6. I'm also going to write that that's 60 hundredths, which is 0.60. It's good to remember that all of those are equivalent to each other. So that means I'm going to shade 6 strips or 60 units, which of course is exactly the same thing. Okay. Number 7 and number 8. There's a lot to read. I think drawing pictures is very helpful for 7 and 8. So let's go ahead and look at number 7. Daniel collects baseball cards and keeps them in a special binder. Each page holds 9 baseball cards in a 3x3 array. Let's draw that. Can you imagine a binder just for baseball cards? And my guess is it has like little plastic sleeves in it. So you can slip the baseball cards in and keep them protected. And it says 3 by 3. So imagine each page looks like that, right? Where it can fit 9 cards, okay? It says that the first page is 4/9 full. The second page is 1/3 full. If Daniel put all the cards onto just one page, what fraction of that page would be full? I think this. If the denominators are not the same, I am going to rewrite 1/3. I'm going to rewrite that. I know that 1/3, if I tripled the top and tripled the bottom, 1/3 is the same as 3/9, which is like one column of that page. Okay, so his first page is 4/9 full. So I'm going to shade in 4/9. The second page is 1/3 full. If he put all of it onto one page, I need to write in or draw in that second page. And I know that 1/3, I just figured out, is 3/9, 3 more cards. So I'm going to go ahead and shade in 3 more. So he's combining his first page and his second page. And I can see that all together, 4/9 plus another 3/9, which is 1/3, is going to equal 7/9. So my final answer is 7/9 of the page. And really, mathematically, what I was doing was 4/9 plus 3/9 equals 7/9. Mathematically, that's what I was doing. But drawing a picture can be really helpful for really wordy word problems. All right, the challenge. Sienna also collects baseball cards in a binder just like Daniel's. Her last page was 6/9 full, but she gave 1/3 of them to Daniel. This is the part that I misread the first time. I want to really focus in once I get started here. 1/3 of those cards. That's kind of the tricky part of this problem. Okay, I'm going to draw a picture as well. If Sienna is giving cards to Daniel, I hope you're thinking subtraction. She had cards, she gave some away, so we're going to be thinking subtraction. So I'm going to go ahead and draw another picture. Let's see if I can just clone this. Almost. Let's go ahead and add one more line in there. Okay, so I have a picture of the page, and it says Sienna has 6/9. So I'm going to go ahead and shade in 6/9. Now, it says she gave 1/3 of those cards to Daniel. So not 1/3 of a page, 1/3 of these 6 cards. Can you imagine splitting these cards into thirds? There's 1/3. There's another third. There's another third. So it's not 1/3 of the page. It's 1/3 of those cards, which is 2 cards, right? 1/3 of those 6 cards would be 2 cards. So she's giving 2 cards to Daniel. 1/3 of her cards to Daniel. I am literally going to flip my pencil around. Up here it's my smartboard eraser, but flip your pencil around and erase 1/3 of those cards. And those are what she's giving to Daniel. So I'm going to erase that and that. What fraction is left? 4/9 of the page. Is my final answer. So again, the confusing part was not she gave 1/3 of the page, 1/3 of a whole page to Daniel. She gave 1/3 of her cards to Daniel. Okay, letter B. Can Daniel fit cards from his first page, his second page, and the cards Sienna gave him all on one page of his binder? So again, I'm going to use a picture to help me out, and I'm going to draw a page. Daniel's first page, if I look up at number 7, Daniel's first page was 4/9. So I'm going to shade in 4/9. That's his first page. Now he's combining it with his second page, which was a third of a page, which is 3 more cards. So I'm going to shade in 3 more cards. And then we're also combining what Sienna gave him. And Sienna gave him 2 cards. Well, look at that. That worked out just perfectly. So the question is, can Daniel fit the cards from his first page, his second page, and the cards Sienna gave him all on one page? The answer, of course, is yes. Our picture is a fine explanation, but you also could show it with numbers. His first page was 4/9. His second page was 1/3 of a page, which of course was 3/9. And Sienna gave him 2 cards, right? That was 1/3 of her cards. Sienna gave him 2/9 of a page. And all together, 4 plus 3 plus 2 is 9/9, or 1 whole. So the answer is yes. All right, here are the answers for home connections 65 and home connections 66. All right, kiddos, see you in class.